given a linear system of three equations to solve for three unknowns, the first step is to pick any pair of the equations and then solve for one variable. Number two, we're going to pick another pair of equations and solve for the same variable. Number three, now that you've created a system of two equations and two unknowns, we're going to solve the resulting 2 by 2 system. Number four, we're going to back substitute known variables into any one of the original equations and solve for the missing variable. So for example number 2, we're going to find a solution to the following system. So here we have our three equations. So when we observe our three equations, we're going to take a look at them and say, okay, which one would be the variable that we can easily eliminate? Now, there will always be several choices as to where to begin, but the most obvious first step here is to eliminate the x by adding equations 1 and 2 since they are opposite signs. So we're going to write down equations 1 and 2, and we're going to go ahead and then add those equations. When we add the x's together, that gives us 0. So we eliminated the x variable. So now 3y minus 2y is y, 3z minus z is plus 2z, and 9 minus 6 is 3. So now we've created a fourth equation where it's y plus 2z equals 3. Now our second step and what our goal is now we need to eliminate using two different equations, and we need to eliminate x again so that we can end up with an equation 5 that has the same two variables y and z. So the second step is to multiply equation 1 by negative 2 and then adding the result to equation 3. And these two steps will eliminate the variable x. So the first equation, we're going to multiply that by negative 2. So we get negative 2 times x, which is negative 2x. Negative 2 times negative 2y is plus 4y. Negative 2 times positive 3z is negative 6z. And negative 2 times 9 is negative 18. And then we're going to keep equation 3 the same. So now what we can do is we can eliminate the x variable again, which again, that's what we want to do. Negative 5y plus 4y is negative y. Negative 6z plus 5z is minus z. And negative 18 plus 17 is negative 1. And so now we've created equation number 5. So in equations 4 and 5, we have created a new 2 by 2 system, and then we can solve for z by adding the two equations. So equations 4 and 5, we're going to be able to add those together to eliminate the y variable. So we get 2z minus z, which is z. 3 minus 1 is 2. And now next, we're going to back substitute z is equal to the 2 into the equation 4 and then solve for y. So we get y plus 2 times 2 equals 3. 2 times 2 is 4. And if we subtract 4 to both sides, now y is equal to negative 1. Now that we have z and then y, we can then back substitute where z is equal to 2 and y is equal to negative 1 into equation 1, and this will yield the solution for x. So we have x minus 2 times negative 1 plus 3 times 2, which is equal to 9. So we get positive 2 plus 6, which is 8. So x plus 8 equals 9. Subtract 8 to both sides. 9 minus 8 is 1. So therefore, the solution is the ordered triple, where the value of x is 1, the value of y is negative 1, and the value of z is 2. So that means you'd have three lines in a plane that intersect at that point, or the ordered triple.